Hi Year 11, welcome to your first lesson this week, and this is the final lesson in a trilogy of lessons about different cycles within nature. The first was the carbon cycle, the second was the nitrogen cycle, and today we're going to look at the water cycle. And the water cycle is by far the simplest of these three cycles, and it really shouldn't take too long to look at. So once we're done with that, we'll go on to look at how we make potable water, which is just a fancy way of saying safe, drinkable water. So just like those other two cycles that we looked at, the water cycle is made up of some processes that we should be already very familiar with. The first of which, and where the water cycle begins, is through this process of evaporation. Water on the ground gets heated up by the sun and it evaporates. And because it's heated up, the space between those water particles gets greater, the volume gets greater, and so the density decreases. And as my water evaporates, it rises up into the air. And as those water particles climb up into the air, they cool again. It's much colder high up in our atmosphere than it is down on ground level. And because they get colder, those particles get closer together and condensation occurs. And this is what clouds are. They are water that has been evaporated and then condenses in the cold atmosphere above. Once enough water condenses in this way and the cloud becomes great enough, big enough, and becomes dense enough with that water, it begins to fall in the form of precipitation. And precipitation is generally rain, but it can be any number of different things. Those that take geography will be very familiar with this phrase precipitation, but it's snow, sleet, that kind of thing. And this precipitation, when it falls on trees, it falls on the ground, it might fall into lakes, reservoirs, rivers, all these kinds of things. Eventually, all of that groundwater, that fresh water, will eventually make its way back to the ocean if given enough time. It's this flow of fresh water from wherever it falls to the ocean that allows nutrients to be sucked up by plants. So the water cycle supports all life on Earth indirectly, as well as directly through allowing us and other animals to drink. What we can look at now is how we are able to make this water that falls from the sky through precipitation, how we're able to make it safe to drink, and how when we turn our tap on, we are able to get nice, safe drinking water out of it. And the science word for drinkable water is called potable water. And the process through which fresh water, which is to say water without salt in it, becomes safe to drink is the same pretty much anywhere in the world. There will obviously be slightly different steps depending on the exact country and indeed the exact area of the country, but pretty much the same process applies wherever. So let's take a look at that process now. And it begins with a collection of water. This might be a natural reservoir, a ditch in the ground that fills with water, or it might be something man-made. But we allow that rainwater, that fresh water to collect. But it won't just be water in there. It will be lots of dead things, twigs, there's always a dead hedgehog in there, a trolley, this kind of thing. There will be a load of waste in there that means that it's not safe. And so our first step is to go about removing that. And to remove this large debris, we just go through a process of filtration. All that water is taken out of that natural reservoir or man-made reservoir and passed through a filter. And this just means something with gaps in it that allow the water and smaller particles to pass through, but it blocks that large debris, my dead hedgehogs, my twigs, that kind of thing. And what we then end up with is a volume of water that is free of any large debris, but that does not mean it's clean and does not mean it's safe to drink. That filter will not have removed any smaller particles. Things like sand, little bits of dirt will still be floating around in there that we don't want to drink. So what we do is we allow this process of sedimentation to occur. And this really just means leaving my volume of water until all those small particles that are floating around in it, they will gently over time float to the bottom of my container of water. That means that the top layer is nice clean water, the bottom layer is my dirt, my sand, my other things. This is just a naturally occurring process. It's why there's grit and sand at the bottom of rivers and lakes. Once sedimentation has occurred, you can just pull that top layer of clean water off and it will leave all the sand and dirt behind. And then you have got some water that is clear of any particles, any solid matter. However, what you will not have removed at this point is any microbes. You might still have pathogens floating around in there that mean that water is not safe to drink. In order to sterilise and clean the water at this stage, we add chlorine, much like we do in swimming pools, but just in a slightly smaller quantity. And that just kills any of those microbes, any of those pathogens, and leaves it safe to drink. While that water may then be safe to drink, it does not mean it will be completely free of pollutants. There are still some compounds that can get into water in low levels which can cause issues should those levels raise higher. So lots of drinking water comes from lakes and reservoirs, and it can be that fertiliser finds its way into those lakes and reservoirs. Fertilisers used by farms can wash in there after rainstorms, and fertilisers contain nitrates, which can cause some really serious health problems if consumed in high enough quantities. So all drinking water is checked for the levels of nitrates. And the same is true of pesticides. Any pesticides used on farms can wash up into our drinking water. And the final possible pollutant you might find in your tap water, your drinking water, is lead. Old pipes in houses were made out of lead, and as water flows through those lead pipes all the time, small amounts of lead can wash off and be picked up in that water, and then you can consume them. Lead is really, really poisonous, and it's why we don't use it in our pipes anymore. But if you're in an older house, it might be that you've still got some lead piping remaining. There is, however, another way to go about getting safe drinking water. In our country and most countries in the world, we are fortunate to have a decent amount of rainfall, which means we have a ready supply of safe drinking water, of fresh water. Some countries in the world do not get adequate enough rainfall to sustain their population, and so they need to get their drinking water from the ocean, from seawater. And this process is called desalination, and it is basically heating seawater to evaporate off the fresh water and leave the salt behind. That fresh water that evaporates is then captured and used to feed the population, to be used as drinking water, to be used in taps and all the rest of it. This process in chemistry we would call distillation. You are heating it and you are allowing the two liquids, the salt water and the fresh water, to separate based on their different boiling point. However, heating vast amounts of water like this almost constantly to supply drinking water is extremely expensive because it uses loads and loads and loads of energy. And as a result, very few countries can do it or can afford to do it. So Kuwait is one. Because it is an oil-rich country, it can afford to do this to gather its drinking water. But most poorer countries that don't have a ready supply of safe drinking water are not able to do this because it's just far too expensive. Good, so we're just going to go ahead and look at a 6-mark question now based on how we go about making water safe to drink. So this question is all about removing impurities from water and how some substances are unable to be removed. So we'll start by answering it by talking about those three processes, the first of which is filtration to remove large insoluble materials. Then we can talk about sedimentation and how that leaves the smaller insolubles to float to the bottom before being removed. Chlorine is then added to kill any microbes, but none of this works against those pesticides and fertilizers because they are too small to be removed by filtration or sedimentation, and they're not a living thing. They cannot be killed by chlorine. Good, so hopefully that was useful and you can all go ahead and answer the Google questions this week. Remember, there is a second lesson, and I hope you enjoyed the live lesson this week if you joined it. If not, there is a recording of that as well to help you further understand this topic and the session that we will do in our next lesson. Stay safe, bye-bye.